Mm, I'll just share a couple of online stuff. Okay, let's see. Okay, you should be able to see this article, right? Application and
Mhm.
limitation of hash table.
Yes, sir.
So, okay, so there's nothing to implement here because the dictionary as it is can be used here. Okay, so if you talk about hash table, okay, what does it means? There is a key, right? Okay, so they allow you to store and retrieve data using a key value pair. Okay, so key value pair is nothing but our dictionary, correct? So we
Mhm.
can use dictionary as it is in the form for hashing or for hash function. So hash function is a mathematical function that maps a given key to a corresponding hash value or index in the array. So the values in the array will have a key, and and that's what dictionary does. So, okay, some features like hash function should be fast, deterministic, uniform, in that it should produce the same output for the same input, right? So each key should have same value, and that's why duplicate of keys are not allowed. Because if you have duplicate of keys, then you don't know which value will be printed, right? It should be consistent, uniform.
Mhm.
Okay, good hash function should also minimize chances of collision. Okay, when two different keys have the same hash value. So generally, when you talk about data structure, okay, we are talking about storing unique values, whether it is stack, queues. Like if you want to say stack of books, you will not have two copies of same book. Very rare situation you will have. So most of the data structure that we use it for managing, let's say, file system, managing student record, managing library information, things like that. So each message, each information will be unique. Okay. In practice, we can put duplicate and we can use it, but logically speaking, applications will not have duplicate values. Okay. So that's why, we say that in the hash function, let's say if you are storing the location, memory location, or storing the uh, employee ID of the employee table, right? So
Mhm.
all those will be unique,
Okay.
right? So if I need and details of employee ID 100, okay, I should have only one key. I should have only one memory location to which I can go and look for. You should not say, okay, you have A and B both can give you same data. Okay, we don't want to get in that situation.
Okay.
So that's what it says that when two, collision, name collision, we call it as.
Mhm.
Okay, so collision resolution is the process of handling situation when two or more keys have the same hash value. There are different ways to resolve collision, but the most common ones are chaining and open addressing. Okay, so chaining involves creating a linked list of key value pairs for each hash value and appending or searching the list when collision occurs. So when addressing involves find an alternative slot for the key value pair using probing strategies such as linear probing, quadratic probing, or double hashing. Okay, what does that mean? Okay. Um, so chain, what it says is create a linked list of key value pairs for each hash value. Okay, so for each hash value, you have two hash value which are common. So create a linked list so that the reference goes to the key, not to the value. So on addressing involves finding an alternate slot for the key value pair using a probing strategy, such as linear probing, where you go in sequence, line by line, okay, one after one. The linked list, you go in sequence, right? Or double hashing is when you have double linked list kind of thing.
Mhm.
Okay, but generally it should not be. Then performance analysis. Okay, so performance is definitely better than ON. ON is when you have to go through the sequential. Okay, when you have n values, let's say in your hash table, and you have to access each of those n values, so you'll go in sequence. So the worst case is ON, right? The time complexity is going to be like n times, right? And but when you have hash, you will be able. Oh, sorry. When you have hash, you don't have to go in sequence. Okay. Generally, generally we have when we create index, right, on a table, the purpose is that you can use binary search technique or similar search technique, generally binary,
Mhm.
where you don't have to go through entire list to find your value. You figure out the memory location and directly you go there. So it's going to be it's going to be much faster, okay, better than, okay, in best case also it can be like O of n, O of 1 also, where directly are able to find the values. Okay. Okay, so you have key through which you can directly go and get the value. So generally your key has to be unique, right? That's why we're taking employee ID as 101 or maybe employee name. Okay, and the so for example, okay, let me delete it again and redraw to avoid confusion. So let's say if I have a table here, okay, now you have, of course you'll have data in this, right? Now let's say if 105 is here, right, and you have 101 here. Now if you're looking for 101, then you know this will work better than your hash table, okay? But most of the cases, okay, what happens, you are iterating through list one by one. Now if I say give me the details for employee ID 105, okay, details for 105 where employee ID is 105. So you're going 1, 2, 3, 4. Oh, here you found, and now you are talking about it. Instead, if I have a table here, okay, 101, okay, 10, okay, and this will be, so when you have key, you can arrange it in that order, right? 105. Let's say here, okay, here also it is 5th, okay, and then you have corresponding memory location 0x something. Now I can use binary search technique for my value. Okay, so how does binary technique work? You go with at the center first. Okay, then you check. So maybe here for 105, I'm taking 5 attempts to find 105. Here within 2 attempts, I can find 105.
Okay.
So you're taking only 2 attempts. But since this is the key, okay, value will be here, right? So
Wait,
this
so
will,
then it just goes to the middle and then it goes to
we'll talk about binary search. So binary search, how does it do is looking at the, let's say if you have index from 0 to 100.
yeah,
Okay.
it'll go to 50 first, right?
Yeah, it'll go to 51st first, middle one, right? If there is no match, then it's going to take the half of this two. So, so in binary search, the condition is that your data has to be sorted first.
Yeah.
Okay, data is sorted. So if I know that the value that I'm looking for 105, or let's say in this case 85, let's say in this case 85, which I'm looking for is greater than this key value, which is your 50 mid value, 55 or 51 rather. So if this is more than 50 or 51, then I know that this is on the right side. I don't have to go through this entire 50 values on the left side. Now imagine if you have 10,000 or 100,000 values. So you're avoiding going through 50,000 values here, right? Now you go at the center, okay? Again, you check, okay, maybe 75, no. So again, that means it is on this side. So next step, again, you're avoiding 25,000 values. Then you come here and then maybe, you know, at mid value, you figured out. So within 3-4 steps, you have reached number 85. And then once you reach here, it has the location. So you can directly go this memory location where you have all the information. So it's like this, when you are, when you go to a colony, okay, look, want to meet your friend. So if they do not have house numbers there, is it difficult to find the house or not? You have to know, if you don't know, going for the first time, you have to knock each door and see if your friend is there inside or not.
Yeah.
Knock each door and ask your friend's name, and if, you know, they'll say no. Now, if the house number is there and it is in arranged order, you can easily figure out where the house is. You will not have to ask anyone. But house number is there, but it is in different order, let's say. Okay, why is different order? Because when you talk about database, okay, you can say that why don't we create a, you know, structure here itself. We cannot create structure on the table because table, you know, you have to perform both update and delete and edit also, right? So you keep change. So imagine, you know, you have a colony where every week they construct the new house, let's say, for example, every week they construct the new house. So today you have only 5 houses. You have 1, 2, 3, 4, 5. Tomorrow somebody constructs a house between 1 and 2. They cannot use 5, right? They have to use 6. Correct? And
Yeah.
then after somebody, after 100 days, house number 100 is between 1 and 6. They construct a house between 1 and 6. Now, between 1 and 6, you have house number 100. Because you are doing editing, every time on the database, it's very difficult to maintain that order in the database itself. So we are creating a hash kind of, okay, index is nothing but a hash kind of structure. Where you say, okay, fine. It's like, you go to, there's a map there at the entrance, let's say. So if new house comes in, map is there. So you can go and see the map. Okay, my friend lives in house number 120 and house number 120 is 5th house from this side, right? It doesn't matter what is the number of 1, 2, 3, 4, 5, 4 houses. Okay, directly you'll go to 5th house and you will get your friend's number, house number. So one thing is there is no address. Second thing is address is there, but it's keep changing because of data getting added, edited every minute. Okay, so you need a hash table which stores you the address. It's like a map. It's like when you enter into a colony, they'll show a map. Okay, computer center is here. Park is here. The house number 120 is here. They might put the so as and when new house is added, the map should be updated with the location of the new house. So then you can directly see. It doesn't matter if the house is not in the order. You can directly see and you can know, okay, this is the area I need to go. I need to take second right, and then after second right, house is on the 5th house after second right on the left side, for example. So irrespective of what house numbers are on the, we don't care. Your destination is 5th house on the second right.
Yeah.
So you directly go with 5th. So this is what exactly hash table provides. Okay. And then your map, what you see on the map, this is what you see on the map. Okay.
So you said there were 2 ways of going to the hash map, right? So could you explain those using this?
Correct. So what we are saying is, let's say if there are, we said that 2 keys have same values, right? That means if you, that means duplicate is allowed here. Duplicate values are allowed. Okay, so you have 105 and 106, and both they talk about this, the same data. So in that case, what they're saying is you can create a linked link-like structure. Okay. So link-like structure, you have 105 and 106. Now, if you're going sequentially, you will always end up at 105 only. Okay. Or you can have double linked list 105. Okay. You have this value, and this value connects to another set of value. So now you know that whether it is 105 or 106, you have to reach to the same set of values.
Okay.
Because both of them are having those duplicate values in the same. So whether you reach 105 or 106, you still get the same data. So you put those, keys together. Okay, and both of them will. So that's called chaining. Okay. What was the other thing? Let me just go there once.
Okay.
So that is an example of pattern matching. So you create your pattern, and then that pattern becomes your key, and and that you are checking for the value in the hash table, which entire becomes your table. And these are some of the problems in hashing. Okay, I have not seen them, but what we could do is we could, you could go to some of these and see if it makes sense or not. Right? They have the programs here. So what it says is, given endpoint on a 3D plane as a pair of XY coordinates, the form of 2D integer array. Okay, so these are sometimes, and data structure. Okay, see, in reality, if you are developing any programming language or you are working with low-level language, only you will get to develop. Okay, because most of these popular algorithms have already been implemented and it's available. So if you are using, let's say, if you are working in a company where they are using Python to develop some of these advanced level things. So these things already there. So you don't have to worry about, how to use. Okay, for example, in the list we have seen sorting, right? We
Mhm.
don't need to know which sort is being followed inside. Okay,
Yeah.
you want to call sort, you call sort and get your work done, and you move it, because your focus is not on sorting, your focus is on the business logic. But if
Mhm.
you are working with algorithms itself, where you want to improve the algorithms, then you need to know which algorithm you're talking about. So mostly, okay, 80% of the role will be for you to use the data structure, not as to develop. But yes, 20% chances that you will end up getting in that kind of role where you are going into the design aspect. So that's why
Mhm.
it's important to know. But
Oh,
definitely they'll ask you question in the interviews. Okay, whatever job role you go, if you're going for a programming role, data structure is the favorite topic for people to ask questions. So see here, it says that this is for Amazon and Google. Uh,
mhm.
so what it says is, if you have endpoint on a 2D plane, so 2D plane means, think of it as
X
a
and Y.
matrix, yeah, X and Y,
So
matrix
I don't
kind of.
understand why we need what's it called, hash table for this. We can just iterate it through two
Yeah, yeah,
fold.
yeah. Let's see. See, iterate through the, how do you iterate? See, in hash table also you're iterating only, right?
Yeah, yeah.
See, hash table also you're iterating only. Only thing is the way you iterate is different, is faster than normal iteration. You're
Mhm.
not going one by one.
Yeah.
So given endpoint and 2D plane as a pair of XY coordinates, okay,
We just have
integer
to see
array,
which one has same in like one,
array,
1, 2,
size
2.
of array to the program if a maximum number of points which lie on the same line.
Yeah.
No. See, same line means what? The line could be X line or Y line, correct? Your line could be X axis or Y axis, correct? Now you
Yeah.
tell me what happens on X axis and Y axis. Okay, let me go back to Paint again. Uh, that share. So let's say you have X and Y axis here. Okay. Now if I draw a line here,
Yeah.
and let's see if I draw a line here. So on this line, which is parallel to your x-axis,
Yeah.
okay, what will be the values here? Okay, let's say if this is y is 2. So it can be x comma 2. Anything comma 2 means they are on the same line,
Yeah.
correct? Or if you take what this line here, x is, let's say, fixed 3. That means 3 comma y. Anything, okay? So these are your points which lie on the same line. Now let's go back to the question here again. So if you look at here, 1 comma 1, 2 comma 2, definitely they are not on the same line. But you see 1 comma 2, that means 2 comma 2 and 1 comma 2, they are on same line, right? Now,
But the answer is different, sir.
no, wait. Answer is maximum point. So,
Like
so
the
if,
explanation I meant.
yeah. So here you see, these are on the same line,
Mm-hmm.
right? Now you see this 3 comma 3 is some, and so now these are the points which are on where y value is constant, right? So on y axis you'll figure out that these two are on y axis and these two are on x axis. These two are on y axis and these two are also on y axis, but different parallel line, right?
Okay.
So on y axis these two form y axis and these two form another y axis. Now, so we figured out that these 2 points lie on y axis, 2 on y axis. Now we have to look at from x perspective. X perspective means the first value will be common. So this 1 comma 1 and 1 comma 2, they lie together.
Mm-hmm. 2
2
comma 2,
comma
2
2
comma
and
3.
2 comma 3 lie together,
Yeah.
right? So now you have how many points? So there are 3 points which lies on the same line, and all of their count is 2, 2, 2, right?
How do one, but in the explanation says 1 comma 1, 2 comma 2, 3 comma 3. How do these 3 points land on the same line?
No. So they're not talking about 1 comma 1, they align the same line. What they're okay. So this is on x-axis, y-axis, right? Now,
Yeah.
one thing which I missed is, let me take you to the paint here. Now, you can have any line. Did it say that it should be horizontal or vertical line? No. It says any line. So, 1, 1, 2, 2, 3, 3 will form this 0, 0, right? On this point you will have, right? So you have 1, this could be 2, 3, 3, I mean 2, 3, 2, 2, and 3, 3, something like this. So on x-axis, we have two x-axis and two y-axis, and both of them have 2, 2 points. But this, this coordinate, this has 3 points on it. So which one has the maximum? This axis, not the y and x-axis. So they have the maximum point. Got it? So your this line 1, 1, 2, 2, 3, 3, they'll also be on same line. And this will be like multiples. If it is 1, 1, it will be 2, 2, 3, 3. If it is 5, 6, then it will be 10, 12, 15, 18 will be on the same line. Okay. Now you see here. On this side, you have 1, 1. Okay. And so 3, 2 is definitely not on the same line. Okay. Okay. Now you see 3, 2. Okay. 5, 3, not on the same line. But 4, 1. See, 4, 1 is increasing by one value. 3 plus 1, 4, 2 plus 1. Okay. So they could be on same line. So there has to be some kind of relationship between those points. Okay. Now the question is, how do you solve using answer they have not given, right?
No.
Ah, good. Okay. So we could figure out. Okay. We'll figure out. Even I'm seeing it for the first time, we'll figure out. Okay. We can talk about it.
Okay.
Okay. So this is the pattern. Okay. First I have to design the pattern here. What is the pattern? Now 3 minus 1. Okay. Or 2 minus 1. Or 3 plus 1 or 2 plus 1. Same number you should add and subtract. So when you see 3, 2, 4, 1, so it is increasing by 1, it is decreasing by 1. Okay. Okay, it is decreasing by 1, decreasing by 1, increasing by 1. Here, 3 minus 2, right? 3 minus 2 and 4 plus 2. So since we are doing plus and minus, this will be line going towards opposite side. Not, see, when it is all increasing, right? You will get line that we got other way, other side. Here you will get a line which is going opposite side. Okay, so I'll show you what I'm trying to say. You will get a line something like this, where x is increasing, y is decreasing, or other way around. Okay, x is decreasing, y is increasing. Okay, you can have 4 combinations where x is increasing, y is increasing. This is an example. This black line is an example where x is also increasing, y is also increasing. Okay, this is the example where x is increasing, y is decreasing. Or you can say y is increasing, x is decreasing. You can have both decreasing. So both decreasing is same line. See, this line is, you can say x is increasing, y is increasing, or x is decreasing, y is decreasing. So what I'm trying to say is 4, 4, 3, 3. Okay, decreasing, or I can say 5, 5. These are values on this axis, whether it is increasing or decreasing. So if x decreases, y also decreases. If x increases, y also increases. Okay, directly proportional. So you'll get it on this axis. Now, the case that we have now is 5, 3. If x decreases, y increases, right? And if x increases, y decreases. So this is inversely proportional. You get a line like this. Okay, so they are on the same line. So relationship should be that way. They should increase or decrease by the same amount. Then they're on the same line. Or one is constant, other is increasing. Other is constant, other, one is constant, other is increasing or decreasing. That becomes your line parallel to x-axis or y-axis. What is not changing, what is fixed, is the line, is the, if y is fixed, then is the line parallel to y coordinate, y-axis. If first value is fixed, that means you have a point which is parallel to x-axis. So line need not be only parallel to the axis. It could be like this or like this. Okay. So maybe we can try this, and I also work on it to see if we can figure out.
Yes, sir.
Okay. Let me save this link. Okay. Good link. I'll put it in the WhatsApp only better. In fact, let me share the main link only, this link. This is better. You'll have other questions here. So these are all like pattern matching. That's the pattern. What we just figured out is pattern. So look for anywhere we are doing the pattern matching, hash algorithm can be used. So you have a bigger value set and you have a smaller set. So smaller is the pattern that you're finding in the bigger pattern. So you find all the patterns. Basically, the work here is that you find all the patterns and count. Okay, pattern number 1, 2, 3 occurrences. Pattern number 2, 2 occurrences. Pattern number 3, 5 occurrences. Which pattern has the maximum occurrence? Okay, 5. So this is your largest, right? That's how we are going to do that, solve that problem.
Yes.
Okay. Okay. So that's about hashing. So from our perspective, it is easy because, I mean, from programming perspective, it is easy. It's a dictionary. But obviously, implementation is
Difficult.
can get typically. Then the next topic that we want to talk about is binary tree.
BST. Okay.
Okay, BST. So binary tree, okay, has a property, right? We'll see the implementation tomorrow, but we'll look at the property here. So binary tree, as the name suggests, it means what it has. Let me teach you the painting.
So I can only see a Google screen if you're doing something.
Yeah. I'm moving now. Okay. So you talk about, okay, a parent node.
I think I know like the theory about binary trees.
Right. Correct. So, I'll just tell you, okay, so maybe you can see the implementation. Now, how do you implement a tree, binary tree? Okay, we'll have to create our own class, just like we created class for, yeah. So each of the tree will have the data and left node and right node, right? Very much like double linked list, but double linked list is a linear implementation. Okay, this is not linear. Okay, so this is not linear, and there's another property. Okay, this value will be greater than, parent value should be greater than the left child, but smaller than the right child value. Okay, so each node will have at max, if it is not the last node, it should have 2 nodes, right? Each parent node, each node should have 2 nodes only, left node and right node. Right node value should be less than the node value, and right side node value should be higher than the node. So here, the way you add or delete becomes different. Now, if I add, let's say, a 2 to this, okay, I cannot put directly here 2. Though in this case, it makes sense. Okay, 2 is less than 3, right? So it makes sense, totally sense. But let's say if I give you 8 here. Now, if you put 8, now you see it is not fulfilling our requirement of BST. So what happens? Swap will happen. 8 will go here and 3 will come here. So 3 comes here, 8 goes here. But now again you see 8 and 5, they're not matching the BST rule. So now 8 will go here and 5 will come here. Okay, so you will end up getting 8, okay, 5, 8. Now if 8 was like 18, let's say, okay, then again you won't stop here. 18 will come here and 8 would go there. And here you have 5 and 3, right? So 3 will remain like this. So 3, 5, 8, 8. If it was 18, then again you had to swap here, and then 8 would have gone there and 18 would have come here. So first you have to check, is left side okay? Okay, if left side is okay, then you check for right side. Is right side okay? Yes, right side is okay. Then you stop. Okay, so this is how your binary search tree works. So if you are adding, okay, you have to make sure that it is in the same order, and same thing happens when you are deleting. Okay, in adding you will give a number, and that number you will figure out where to add. In deleting you will take a number and you figure out from where to delete that number.
Yes.
Now let's say I want to delete, let's say this is 2 and I want to delete 3. Okay, so if I delete 3, then obviously from left or right, the left one should go up here, isn't it? Because left one is smaller. So left will go here. Okay, right will be here. Okay, or if you want to make it balanced, then what happens? The right one should go here. Because see, now you have one tree here, 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 and here. Now, if I delete any one value from here, obviously this node should go away. You cannot have a node like this. Okay, this node should go away. Now, if this value gets deleted, okay, this should go here, and then you will have this value like this. So okay, so these are the things that you have to understand when you're doing deleting. Okay, so this is about deleting or adding. Then you have features like traversal. We call that in traversal, post traversal, right? In order, post order, and pre order. In order means left, center, right. Center is always at the center. Okay, left will be at the left, right will be at the right. Post order means
Post order means the right, right?
right. Okay, so it is the root node is last. Okay, so post means, see, post means everything. We talk from the node perspective, the parent perspective. Post means that comes later, correct? So the root node should come later. 5 should come at the last. It doesn't matter how many trees you have. This is the parent of all of them. This should be the last one to come. Okay. And then obviously you have left and right. So left, right, head, last. Pre means the head should go first.
Yes.
And the left, right remains like that. Left is always left, right is always right. Okay, so we'll take examples and we'll see. Okay, and this again, there is no inbuilt data structure for this. So we will have to build this binary tree structure.
Okay.
Okay, so yeah, so this is about your binary tree hash table, and then we'll get down to then sorting.
Yes.
Right? So sorting, okay, there are different types of sorting. Let's look at some of the easier one first. Why I'm not able to select again? Yeah. Sorting obviously means, you put them in an order, correct?
Yes.
And the easiest of all is bubble sort. Okay. What is bubble sort?
Not sure.
Okay. So see, bubble sort and linear sort. Okay, these are two basic sorts. So how I remember is, okay, sequential sort. Okay, it's also called as sequential sort. BB. Okay, they are together. Bubble, right? So if you have numbers, let's say 5, 10, 8, 3, 25, 45, and let's say 2. Okay, so you start from left, and let's say your intention is to do the ascending order. Okay, so you start from left. You compare two values together. Are they in the order? Yes, right? You want lower value to be on the left, higher on the left, and higher to be on the right. So it matches. The next iteration, you check for 10 and 8. No. Now you replace it. So it becomes 5, 8. Now 10 and 3. Are they in the order? No. So replace it. Interchange. So 3 and 10. 10 and 25. Are they in the order? Yes. So 10 will remain. Now 25 you have to check with 45. Are they in the order? Yes. So 25. Now you check 45. Okay, with the 2. Are they in the order? No. So interchange 2 and 45. Okay. So in the first iteration, you have done n iteration, right? Comparing 1, 2, 3, 4, 5, 6, right? So this is how you compare in the first iteration. So after end of first iteration, you've got the highest value. So now next time what you have to do is you only have to compare these two values, because this one we have already fixed. Same logic, 5 and 8, okay, order. 8 and 3, no, you have to change it. So 5, 3, 8 and 10, yes, so 8 comes here. 10 and 25, yes, it comes here. 25 and 2, no. So 2 and 25. Okay, so 25 is fixed here.
Yes.
We are not going to, so so if you have 7 elements, you have to run how many times? 6 times. Why? Because last row, okay, let's do it and then we'll talk about that. In the next row, what happens? Okay, 3 and 5. Okay, no, but yeah, 3 and 5, 8 is higher. 8 and 10, 8 remains. 10 and 2, 2 and 10. So 10 will come here. In the next iteration, 3 and 5 remains like that. 5 and 8 will remain like that. 8 and 2, 2 comes here, 8 comes here. Now here you have 3 and 5 like that. It becomes 3, yeah, 3, 2, 5. Then you have 2, 3, 5, right? So 5 anyway, we don't do 3. Now next step you have only 2, right? So if you have just 2, you don't have to compare 2. So the outer loop is going to run n minus 1 times. Because see, if you have 7 elements and if you are able to fix the position for 6, 7th is the default position, isn't it?
Yeah.
Right? You know, if you have 7 people and 7 chairs, if 6 people sit on the chair, then 7th one will have no option.
Okay.
Right? So the outer loop is going to run, okay, n minus 1 times. Correct? So outer loop is keeping track of each iteration, each set of iteration. 2, 3, 4, 5, 6. Okay. So outer loop will run n minus 1 time. Now inner loop is comparing the value, okay, and every time it is getting down less by less. So first it will be n minus 1, then n minus 2, then n minus 3, then n minus 4. Okay. This is very much like, you have done Python also with us, right?
Yeah.
So this is very much like this kind of pattern.
Or the star pattern.
5, 4, right? 3, 2, 1. Is it not?
Yes, sir.
This is the kind of pattern, okay, this bubble sort is following.
Mm-hmm.
So, okay, so you'll have, let's say, I between n and j, where you have n minus I, right? First n minus 0, n minus I minus 1, because you have to do minus 6 times. So n minus I is n minus 0 minus 1, then n minus 1 minus 1, then n minus 2 minus 1, so on. It decreases, correct?
Okay.
After that, okay, then you have to swipe. How do you swap? You swap j of, if j and then next value. If j starting from 0, then j and j plus 1.
Okay, sir.
You're comparing. If j is greater than j plus 1, if j is greater, then swap. Otherwise, don't do anything. J and j plus 1. You're comparing the same two values together. That's your bubble sort.
Mm.
Okay. So we'll stop here today. We'll continue tomorrow. Okay.
On Monday, sir?
On Monday. Yeah. Want to meet tomorrow?
I'm actually kind of busy tomorrow, so I have something.